All right, first step, proactive tuning. The choices you make before you even hit deploy can have a huge, huge impact. We're going to start with Cloud Run because some of its initial settings are just perfect examples of this whole idea. So your first big decision with Cloud Run is the execution environment. Now, Gen 1 is still around for simpler, older stuff, but really, Gen 2 is where it's at now. And for the exam, you've got to know the why behind this. Gen 2 gives you full Linux compatibility and way better CPU performance, which makes it the no-brainer choice for any new service you want to be fast. Next, we've got a really critical setting, CPU allocation. By default, Cloud Run is trying to save you money. It throttles the CPU all the way down to 0 when it's idle. But what if your app needs to do some background work, like warming up a cache? Well, that throttling introduces latency. By setting the CPU to always on, you're telling it to keep the engine running, which is absolutely essential for services that can't afford any kind of spin-up delay. Okay, let's paint a picture to make this real. Imagine a team moves their PHP API over to Cloud Run. All of a sudden, they start seeing these super frustrating random latency spikes, especially when a request hits a cold instance. So what's really going on here? And wow, just look at the difference on this slide. It's night and day. With the default CPU throttling, the P99 latency, and remember that's the experience for your unluckiest 1% of users, was a painful 2.1 seconds. Ouch! But just by flipping that one switch to CPU always on, it plummets to 340 milliseconds. The code didn't change one bit, just the configuration. This quote just says it all. The problem was that the app's cache was trying to rebuild itself at the exact same moment the server was trying to handle a new request. And the CPU was trying to wake up from its nap. It was a perfect storm. Getting rid of that throttling let the cache stay warm and ready to go. The big takeaway here? Configuration isn't just a detail, it's everything. Okay, so that's being proactive, but what happens when performance issues pop up in production anyway? Because, they will. Now it's time to put on our detective hats and figure out how to diagnose the problem using Google Cloud's awesome observability tools. First tool in our toolbox, Cloud Profiler. This thing is fantastic. It lets you see exactly where your code is spending all its time, like which functions are hogging the CPU or using up all the memory. And the best part, it does this in production with less than 1% overhead. It helps you find the exact line of inefficient code without having to guess. Now, let's talk about Cloud Trace. In a big system with tons of microservices, finding the source of a slowdown can feel like finding a needle in a haystack. Cloud Trace is like your magnet. The process is pretty straightforward. You instrument your services so they can talk to each other. You capture all the traces. You zero in on the really slow ones. And then you look at the waterfall diagram to see exactly where things are getting stuck. Okay, pro tip for the exam. You absolutely have to burn these key Cloud Run metrics into your brain. You need to be watching your request latencies, checking for CPU and memory pressure. You don't want to get ohm killed. And definitely keeping an eye on those cold start times. Just think of these as the vital signs for your service's health. Now, for GKE Autopilot, diagnostics are baked right in. You just pop over to the Observability tab for any workload, and your core metrics are right there. But the real superstar here is the Vertical Pod Autoscaler, or VPA. It actually analyzes how much CPU and memory your pod is really using, and then it gives you smart recommendations on what to set your requests to. It's a total game changer for avoiding that guesswork that leads to wasted money. And that's the perfect segue into the other half of our brain today, cost. We've made our app fast, which is great. Now let's make it lean and efficient. We'll start with some quick, tactical ways to slash waste just by being smarter with our resources. And the potential savings here are enormous. Check this out. 83%. And no, that's not some made-up marketing number. An 83% cost reduction is totally achievable for the right kind of workload, just by using the built-in features of Cloud Run the right way. Let's see how. So the first and maybe most powerful feature is scale to 0. Think about it. If your service has times with 0 traffic, maybe overnight or on the weekend, why on earth would you pay for servers that are just sitting there doing nothing? With this one setting, Cloud Run just shuts down all your instances, and your compute bill for that service literally drops to nothing. With GKE Autopilot, it's super simple. What you ask for is what you pay for. You don't pay for some giant virtual machine that your pod happens to land on. You pay for the exact CPU and memory you request. This is a critical exam concept. Right-sizing your containers isn't just good for performance. It is a direct lever on your bill. Every tiny little core you shave off an unnecessary request is real money back in your pocket. All right, we've tackled the low-hanging fruit. Now let's zoom out and talk strategy. We're talking about building sustainable, long-term FinOps practices. This is all about bringing financial accountability to the cloud so you can keep your costs under control, even as you grow. Think of this as your FinOps command center on Google Cloud. And for the exam, you'll want to know what each of these tools does. Exporting billing to BigQuery lets you slice and dice your costs any way you want. Recommender is like an AI that just finds savings for you. CUDs give you huge discounts if you have predictable workloads. And budget alerts, well, they stop nasty surprises before they happen. And for any GKE jobs that can handle being interrupted, think CI/CD pipelines or batch processing, you absolutely have to know about Spot VMs. The discount is just wild. We're talking up to 91% off. Now, what's the catch? Well, they can be taken away with short notice. But for the right kind of job, the savings are just way too good to pass up. And finally, one last tuning knob for Cloud Run: concurrency. This setting basically tells each container how many requests it should try to handle at once. The higher the number, the fewer containers you need, which means lower costs. But, and this is a big but, if your app is CPU heavy, setting it too high will actually slow things down as requests fight over the CPU. It's this constant balancing act, right? All about finding that perfect sweet spot. So if there's one single thing you take away from this whole guide for Section 5, let it be this: performance and cost are not enemies. They are two sides of the exact same coin. A well-tuned, efficient, fast service is almost always a cheap service. True mastery, and what the exam is looking for, is understanding that relationship and knowing exactly which tool to grab to manage it. And that brings us to the end. I'll leave you with a little homework. Take a look at your own work, your current projects. Which one of the optimizations we talked about today, whether it's CPU allocation or using Spot VMs, or just scaling to zero, which one would be the biggest game changer for you right now? Thanks for watching.